morning, class. This is Teacher Jovi welcoming you once again to our virtual classroom. If you haven't subscribed to this channel, please subscribe now and also click the notification bell so you can be notified when a new video is uploaded. For today, our discussion will be about the inverse of one-to-one function. For our objectives, after going through this lesson, you are expected to determine the inverse of one-to-one function and write a letter to a family member or peer about making amends on regrettable events which cannot be undone. Let us start with our basic concept of one-to-one functions. Let's have this activity identify whether the function is one-to-one or not. Number 1, f of x is equal to 3x plus 8. This is a one-to-one function or not? Notice that we have 3x plus 8 here, and this one represents a linear function. And a linear function has a graph of a straight line. And for a straight line, when we do the horizontal line test, we will notice that the graph will intersect the horizontal line in just one point. This means that the linear equation or the linear function satisfies the horizontal line test, and therefore this one is a one-to-one function. Number 2, we have q of x equal to 4x squared minus 2x plus 5. Is this a one-to-one function? Notice that our degree here, the degree here is 2, and this one is a quadratic function. For a quadratic function, the graph is a parabola. And when we do the horizontal line test, the graph will intersect the horizontal line at two different points. Therefore, this graph does not satisfy the horizontal line test. Thus, this quadratic function is not a one-to-one function. Number 3, we have r of x equal to 3x minus 2 all over x plus 1. X plus 1 here is a denominator and it should not be equal to 0. Thus, x should not be equal to negative 1. This is a one-to-one function. Next, we have number 4, g of x is equal to x. Is this a one-to-one function? Okay, so we notice here that x here has an exponent of 1. Therefore, this is a linear function. And as we have said a while ago, a linear function is one-to-one. Thus, g of x equals x is a one-to-one function. Let's have number 5. m of x is equal to x plus 2 squared minus 1. Is this a one-to-one function? Okay, so let's notice that we have here a square, which means that the degree of this function is 2, and therefore we have a quadratic function, and the quadratic function is not a one-to-one function. So let's try this guessing game. Think of a number, preferably choose between 1 to 10. Multiply that number by 2, then subtract by 1, and then we add 5 to the difference. Now, tell me the resulting number. So let's assume that my resulting number is 18. Can you guess the number that I had in mind? So here's how it works. We let the number that I had in mind be x. And then we do the operation, multiply it by 2, then subtract by 1. So we have 2x minus 1. And to the difference, we add 5. So we have 2x minus 1 plus 5. And simplifying this, we have 2x and then negative 1 plus 5, that is positive 4. Therefore, we have 2x plus 4. And this is now our equation for the given instruction. For us to find the number that I had in mind, we will undo our operations in this equation. So our last operation is addition. We added by 4. So we undo that by using the inverse of addition. So we have subtraction. We subtract by 4. And then we had the first operation here. 2x, which is multiplication. So the inverse of multiplication is division. Therefore, we divide this by 2. Okay? So to find the initial number or the number that I had in mind, okay, for the resulting number 18, we will subtract by 4. So we have 14. 18 minus 4 is 14. And then 14 divided by 2 is 7. Therefore, the initial number, the number that I had in mind, was 7. Now, let's proceed to finding the inverse of a function. The inverse of a function may be solved intuitively. Let's have this first example. We have f of x is equal to 3x plus 8. We can actually use the concept that we had in the guessing game in this example. So for our solution, the last operation performed is addition. And the inverse of addition is subtraction. So 2x, we subtract 8. So here we have x minus 8. Okay. Second step, the second to the last operation is multiplication. And the inverse of multiplication is division. Therefore, we divide the whole thing by 3. So we have x minus 8 all over 3. And then equate it to this notation. We call it f raised to negative 1 of x. And this is to denote that it is the inverse of f of x equals 3x plus 8. So there we have f inverse of x is equal to x minus 8 all over 3. So just to remind you class that this one is read as f inverse, or the inverse of f of x. We call it f inverse of x. Let us look at other examples. So find the inverse of this function. F of x is equal to 5x minus 3. Notice that our last operation here is minus 3. Therefore, to x we add 3. And this one is multiplied by 5. So to the whole thing we divide it by 5. So the inverse of the function will be x plus 3 all over 5. Second, g of x is equal to 7x plus 11. Okay, so our last operation is plus 11. So to x, we subtract by 11. And then we have here times 7x here. So we have multiplication. Therefore, our inverse for that is division by 7. Therefore, the inverse function would look like g inverse of x is equal to x minus 11 all over 7. And here's the third example. M of x is equal to x minus 12. So this is our last operation, negative 12. So to x we will add 12. Okay, so we have x plus 12 there. And then this one is 1 times x. Therefore, we have to divide the whole thing by 1, which is no longer, we no longer write it. Therefore, we have the inverse of m of x is equal to x plus 12. We don't write the all over 1 here anymore, so we only have x plus 12. Example number 2. Find the inverse if it exists. We have q of x is equal to 4x squared minus 2x plus 5. For our solution, we notice that q of x is equal to 4x squared minus 2x plus 5 is a quadratic function. We have here 2 as the degree. And the graph of this function is a parabola. And a parabola fails the horizontal line test and is not a one-to-one function. This fails the horizontal line test, and therefore q of x is not a one-to-one function. Therefore, its inverse is not a function. In other words, it has no inverse function. This applies for all quadratic functions and all polynomials with an even number degree. Examples, we have p of x is equal to x raised to 4 plus x cubed minus x plus 1. The highest exponent or the degree is 4, which is an even number. This means that this has no inverse function. And here's another example. We have h of x is equal to 5x raised to 8 minus 4x raised to 5 minus x cubed minus 2x plus 2. So we have here the highest exponent or the degree of the polynomial, which is 8, and another even number. Therefore, this has no inverse function. For our example number 3, find the inverse of f of x is equal to 3x minus 2 all over 5x minus 9. So this is a rational function, and the denominator 5x minus 9 should not be equal to 0. Otherwise, the whole function will be undefined. So for our solution, we will be following these steps. First, we change f of x to y, and then we interchange x and y, after which we will solve for y. This then will give us the inverse of f of x. So let's follow the steps. We change f of x to y, so we now have y is equal to 3x minus 2 all over 5x minus 9, taken from our original function. And then next step, interchange x and y, so we will now change this with x, and the x's we will change with y. So we have x is equal to 3y minus 2 all over 5y minus 9. And then we solve for y. Okay, solving for y, we will do cross multiplication. X here has a denominator of 1, so we cross multiply x times the denominator here. And then the imaginary denominator 1, we multiply to the numerator. Okay, so we now have x times 5y, we have 5xy. And then x times negative 9, you have negative 9x. And then the imaginary 1 here times 3y minus 2. You have there 3y minus 2. Okay? And then since we're solving for y, we will move all the terms with the variable y to the left side, and those without the variable y we put on the right side. Okay? So we have 5xy, we bring it down, and 3y here we move to the left side, and negative 9x we move to the right side here. So we now have 5xy and then minus 3y. This one is moved here. It becomes negative. And then negative 9x we also move to the right. It becomes positive 9x. And we bring down negative 2. Okay? And then we try to factor this out because we're solving for y. We have to isolate y. We factor out y here. Okay? So we will have y times 5x minus 3. We factored out the y, okay? And then it's equal to 9x minus 2. So to solve this, we will divide both sides by 5x minus 3. So we have, this one will cancel out, and we are left with 9x minus 2 all over 5x minus 3. Okay? Therefore, the inverse of the function will look like this. So we have now the notation for inverse of the function f. We have inverse of f of x is equal to 9x minus 2 all over 5x minus 3. Here's another example with that kind. Find the inverse of t of x is equal to 4x minus 8 all over x minus 3. So we follow the same step. Change t of x to y. So we now have y is equal to 4x plus 8 all over x minus 3. So we just change t of x to y here. And then we interchange x and y. So the y here will become x, and then the x's here will be changed to y. So we now have x is equal to 4y plus 8 all over x minus 3. And then we solve for y. So again, we follow what we did a while ago. So we will cross multiply. We have an imaginary 1 here, x over 1. Okay. So we cross multiply x, we multiply to the denominator here, and the imaginary denominator 1, we multiply to 4y plus 8 here. So let's do that. X times y, we have xy, and then x times negative 3, that's negative 3x. There you go. And then 1 here times 4y plus 8, you have there 4y plus 8. And then again, we isolate y. So we will be transferring the variables y to the other side. So we have here xy, we bring it down here. Positive 4y, we move it to the left, so it becomes negative 4y. And then negative 3x becomes positive at the right side, and we bring down 8 here. Okay, and then factoring out y here, okay, we have y times x minus 4. This one remains here, 3x plus 8. Okay, we divide both sides by x minus 4. X minus 4 also here. Okay, so a divisor x minus 4 here will cancel out with this. So we're left with y. Now y is equal to 3x plus 8 all over x minus 4. And for our notation, we now have t inverse of x. From there, t of x. T inverse of x now is equal to 3x plus 8 all over x minus 4. I hope everything is clear, guys. It's your turn now. Please do your homework given in the weekly home learning plan. So God bless you and have a great day, everyone.